I'm going to rewrite this equation. And while rewriting it, the first thing I look at is to make sure it's in the right form. Remember in transformations, if you have a horizontal stretch or compression and a horizontal translation, it has to be in the factored form in order to do your transformation. This is, so we're good that way. Now, we can go through each of these and we can write from our transformations unit what they mean, and also from our shortcut what they mean in regards to sine and cos graphs. So this 1/4 would be a vertical compression. You would multiply your y values. Vertical compression, you would multiply your y values by 1/4. In our shortcut, and what we notice as a pattern is that means your amplitude is 1/4. Next, the 3 from our transformations unit, that would be a horizontal compression. You would multiply your x value by 1/3. And our shortcut, we found out that our b value helped us figure out our period, and we had a formula that our period is equal to 2 pi divided by your b value. So our period will be 2 pi divided by 3. Plus pi over 6 means that we will go pi over 6 to the left. This is a horizontal translation. And that would be the same with the shortcut or not. We did the same thing when we graphed our sine and cosine graphs. We just shifted the graph left or right. That plus pi over 6 means that we're going to go pi over 6 to the left. And finally, the plus 2 is a vertical translation to up. For our graph, that means that our sinusoidal axis or our center line was at y equals 2. So what we've done here is we've described everything with our transformations unit, and then we also described it with the shortcuts that we noticed. That the a value is always our amplitude. Our b value helped us figure our period, and the d value helped us find our center line. So we've basically done a predict how. We described how this graph is related to the original graph. And now we want to sketch. The first thing that I'm going to do, because this will be messy, put a line through that. We'll change this to at least 1 period. And we'll look at practicing what we did yesterday. And what we did yesterday was we learned the DAB-C. So I'll just, all right, here's our technique for helping us graph. So DAB-C says, start with D. D is our center line. Our center line is at 2. Draw a dotted line with a red pen at y equals 2. We've done the D part. Next, A is your amplitude. Sometimes you kind of think about D and A at the same time because of the scale. So I was already thinking about A. Since the A value is 1/4, my maximum is going to be at 2.25 and my minimum at 1.75. So I tried to space things out so that I could show that already when I was making my scale. We've now done the A value. So we use the amplitude to show where our maximum and our minimum are on our y-axis. So now we've got center line, we've got our maximum, we've got our minimum. The B value helps us figure out our period. We already said that that's equal to 2 pi over 3. Choose somewhere along your x-axis. and mark it and label it with 2 pi over 3. Then wherever you chose, divide that into 4 equal sections. Cut it in half and then cut each of those in half. That will divide it nicely into 4 equal sections. We can label each of those sections. Half of 2 pi over 3 is pi over 3. Half of pi over 3, pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6. We've labeled all 4 sections. Next is the dash. For the dash, we are graphing a sine or cos graph. We are graphing a cos graph. So we have to know from our original cos graph that a cos graph always starts at a maximum. So for our dotted line, we're going to start at a maximum. Then we'll go center line, minimum, center line, and back to maximum. So we draw the graph without a shift, with a dotted line, label those 5 points from max to center line to min to center line to max. Label them very clearly because now we're going to do our shift. In this case, we need to shift pi over 6 to the left. So we look at our scale. Pi over 6 is already on here. It's this distance, so along my axis in this direction, I'm going to go that same distance and label negative pi over 6. And if I'm shifting everything pi over 6 to the left, that's going to move everything 1 section to the left. So I'll take this top point and move it 1 section to the left. This one, 1 section to the left, 1 section to the left, 1 section to the left. And I've graphed it nicely. And we graphed at least 1 period, it keeps on going. So again, if the textbook gives you a specific domain to graph it over, I don't mind if you always just do at least 1 period and do the arrowheads on that. That's perfectly fine. Okay, questions for practice? Please circle question 3, which I already gave you 3 and 8 last time. And I had a little note to remember to factor on number 11.
It says in the sketch the graph and then list the characteristics of the graph.
Yeah, and listing the characteristics we've kind of done already in this part. The amplitude, the period. We could say things about domain and range and zeros, but it's good for that.
So, but in a test, I would have to write down.
I would be more, in a test, I would be really specific saying, I would like to know, can you list what the amplitude is or list what for the characteristics? I'll be more specific. Okay.